Everybody, thank you for coming over. This is our first meetup of the year. We are co-hosting this with the NOAA in DC, basically the same group of people organizing this, but under two different names. This is We have Scott with us today, and Scott is going to give us a presentation slash demo on what a data warehouse is, why do you need one, and how to scale it up and run it for small and large enterprises, small businesses and large enterprises. And that's going to be all in the Google Cloud technologies, right? GCP, or is it
GCP
more
focused, but I mean, we'll touch on all of them
engineering? All right,
basically. Hopefully, mostly cloud agnostic if we can.
cloud agnostic. All right, so hopefully this is going to be an interactive session where you guys can participate and help develop this presentation and get the most out of it. So thank you so much. Just a couple of announcements. So hopefully we will have these a meetup every month, kind of the same like Tuesday, every other Tuesday, 6 p.m. kind of deal. Same stuff here. So look out for those. We have a couple of talks lined up, so look out for more announcements and talks. And if you want to participate, help organize, or do any of that, do let me know as well. We can always use help. Um, with that, I'm going to hand it over to Scott, and thank you for being here.
Thank you. Thanks, Fahim. Happy to be here. As Fahim mentioned, my name is Scott Cronson. I am a data engineer currently. My background's originally in mechanical engineering, but I've shifted over to data for the past 5 or 6 years. I started working at a large enterprise like Fortune 500, which I'll talk about a little bit with relation to data warehousing. And then I spent a little bit of time at a startup, and now I'm working for a local agency in DC called Insomniac Design, where we do a lot of web development, data warehousing, web technology solutions for nonprofit, public health, government adjacent types of organizations in a consulting fashion. So I'm hoping that this talk here will be useful for you guys. I'm going to try and gauge it properly to the different skill level that we have in the room, but I'll probably start with a pretty basic foundation so that way we all come in at the same point and then sort of evolve it from there. So I wanted to start before we jump in specifically about maybe by a show of hands, who has heard of a data warehouse in general before this talk? Okay, most people could. Who has built any sort of solutions on any cloud provider, GCP, AWS, Snowflake, anything like that? Okay. And then by a show of hands, how many people have actually built a data warehouse type of solution before? Cool. Okay. So varying levels of experience with it, good. Hopefully we'll start from the ground and work our way up from there. So brief agenda of what we're going to talk about today. First, why a data warehouse? You might have heard of it, but you might not necessarily know the exact applications and why a company would want to use it. Then we'll talk about what actually is a data warehouse, the different components to it, some of the common tech stacks and architecture and solutions you might have heard of and you'd be using when you're building a data warehouse. Talk about different database types, different data models. Hopefully pull up a little bit of a demo from a GCP solution called Dataform, which is very similar to DBT for working on the data models. Talk a little bit about real-world applications, some future trends, about what else is out there right now, and then get into some Q&A. If you have questions throughout, feel free to just stop me and raise your hand, or I don't want to move past the thing if you think that there's more to dive into there. I'm hoping this will be interactive, so if you do have any questions, feel free to just jump in. So first, why a data warehouse? Most of you, as you saw by show of hands, have heard of it before, but oftentimes the data warehouse kind of evolves from an organization that there's sort of different scenarios. You can have a small organization that might be just starting to stand up, doesn't have a lot of mature software and they're kind of new teams and they're figuring things out, or you have a much larger organization that has a lot more complex systems. But in both scenarios, oftentimes it arises from an unawareness of what data is out there, data that is inconsistent across different systems. Perhaps you have a customer management tool that uses a certain customer naming nomenclature, and then you have another tool that uses different, and you can't reconcile across those. Or you have a finance team that's doing a lot of Excel work, and they know that there's a better solution out there because this is heavily manual, and it's like, hey, automation is available, but we're just not doing it properly. Or you've got different teams that are all doing the same thing, and they're all working with data from different systems, but they're not aligned, or it's not centralized or standardized. So there's opportunity there. So there's a lot of different things that can cause an issue, but a lot of my experience, it comes about from, or a lot of the value really from a data warehouse comes from organizations that, you're trying to use data to make better business decisions. But if you're spending more time trying to understand who's got the correct data and what the proper source of truth is, then you're spending less time on the actual business decision and more time on trying to get to the same foundation to start the conversation. And so data warehouses, I think, are really useful because you can stop trying to decide who's right. You all have a consistent, ideally, set of data set to work with, and then you can actually make the better decisions on top of that. So a number of different reasons that we'll start this, but that's just kind of a couple common ones that come up in terms of the main reason for bringing in a data warehouse. You've said, okay, great, we've heard of these sorts of things at our organization. Data warehouse is something that could be useful. There's not going to be a shortage of tech software salespeople that will try and sell you a solution. That might make sense for you. We'll talk a little bit about later about when go custom versus when buy something out of the box. But just jumping straight into saying, hey, we need a better way to, manage our pipelines or our CI/CD, or we need a better customer management tool or a better way to run our manufacturing process. Let's buy a software that's going to have all that in-house. It's going to have reporting, it's going to have data management, it's going to have access controls, all of that built in. That might be the right route, but the common pitfall I've seen a lot in the past is jumping into just getting sold a flashy piece of new software, and then after you buy it, you realize it doesn't actually integrate with our existing systems, or we can't get the reporting that we thought we would need out of it, or we've now scaled to a point where this is no longer feasible because it made sense when we were smaller, but now we've grown and we need to move to a different software, or we're sort of backed into the existing one because of all of this legacy usage that we've had. So jumping into something without really understanding what the current landscape looks like and knowing what problems you're trying to solve can be a common way to start going down a path that might not be the most valuable. So I have listed out there the driving question of, before you really start figuring out, what technology you want to use, what solutions, who's going to be accessing, how they're going to be accessing, all of that, it's really useful to start by understanding, what are you hoping to unlock through implementing a data warehouse? Why are you building this or buying this or implementing this, using this? Are there specific business goals and insights that you want to achieve? And by understanding that better will hopefully set you up for success in the long term, because you'll be able to start going in the right direction from the start. Any questions on just what we've covered so far briefly? Cool. So now we'll dive a little bit into what is a data warehouse. For some of you, this might be repetitive. For others, I guess, want to just kind of start from a foundation. I think I just have it in terms of a data warehouse is a big library for your business's data. You've got a lot of features that are similar to a library where you're trying to collect information. This could be from flat files, Excel files that are being passed around the organization. It could be from other software platforms that you use, from Google Analytics, from public websites, any number of sources. And you're trying to collect it all into a standard location. Then, like a library has, they've got millions of books, but you don't just have books laid about all around. You have them in shelves. You have the organizational structure to it. And what that structure looks like, what this data model looks like, depends on what your business needs are. So there's not a one-size-fits-all, and it will vary very heavily depending on what it is what your business goals that you're going for are. But trying to organize it into the proper shelving so that way you can access it when you need it efficiently. Which gets to the last point of making it easy to use. You want to have it be you want to have your data discoverable. You want it to be standardized so everybody knows, if they're going to contribute to it, what that looks like. You want the business teams and analysts that are going to be using it to be able to access and find what they need quickly. So taking that kind of high-level approach and diving a little bit deeper, these are the really 3 layers of a data warehouse. The one on the left, the source layer, is included, but these are probably already exist in your existing environment, your landscape. So starting with the source layer, this is what I mentioned. You've already got systems in your organization. Flat files, point of sale systems, manufacturing systems, whatever this looks like, those already exist. The data warehouse really comes into play from that point forward. Data warehouses are generally broken down into kind of 3 layers, but again, based on your use case, you could have 4, you could have 5 if it's particularly complex, you could have 2 if it's a little more straightforward, but a common starting point is 3. You've got your staging layer. So you're taking all the data from your source systems and you're moving it into some sort of staging layer. And we'll talk a little bit more later about what those actually look like. But this is generally kind of just a raw copy of what you have in the source. It's useful to start with just a base replica so you don't actually touch it or transform anything yet, so you know this is what it looks like before anybody's gotten involved with it. Then you would typically have another layer, which is your kind of your core data warehouse components, where you might be doing standard business transformations to utilize the same currency or implement standard date ranges and other sorts of things that might be common across the whole organization, and that you want each of these data sets that you're working with to be transformed in a similar manner. And that goes into a kind of a warehouse layer in the middle. Then the last portion is the consumption layer. This is how users are actually going to access this data. These might all be within the same environment. They might be in slightly separate environments. There's different tools to move them across these different environments. But at a high focus, your consumption layer is optimized for ease of access and in a way that makes sense for business users or analysts or analytic engineers or whoever is picking up the baton after it leaves the data warehouse and making the right business decisions on top of that. And so there's different forms this can take. You have data marts, you have cubes, you have basic tables or views. You can think of kind of cubes as really maybe like a pivot table in Excel, where you can slice and dice the data in different ways, and you can move it around different dimensions. Data marts might be something that you want to copy directly over to another analytics tool, a Tableau or a Power BI, that they can then run visualizations on, but there's already been some data cleansing, quality assurance, and other facts that you've enhanced it within the data warehouse, so it's easier for the users to make use of. But, okay, so then we'll break this down a little bit further. This is the same diagram, but it shows not just the data storage sections of it, it also includes the data movement components. So the same layers as above, but now you see in the bottom with 1, 2, 3, it also includes how we're getting data from each section to the next. There's two main types of data flows. Is data ingestion, you see there on the left-hand side. It starts with batch. That tends to be the most common. And batch processing is when you take data on a regular interval. It might be once a night, once an hour, once every 5 minutes, whatever that is, but you're processing all of that data in batch. And you're extracting it from a flat file or one of these systems, you're loading into the staging layer, or you take it from the staging and loading into the warehouse layer on regular intervals. The alternative is streaming. Streaming is when you have data that you want to look at more real time. So you don't want updating once a night. Instead, you want to know immediately what's the active utilization of this data for, say, if you run like a gaming company and you want to see how many users are actively online right now, or what they're doing, or you're running an e-commerce site and you're hosting a flash sale and you don't want to see tomorrow what the sales are. You want to know how long for this sale should persist because you want to see real-time records of those coming in. So those are scenarios where you would need a streaming pipeline, and you'd use something like Kafka or similar software to accomplish those. Generally speaking, when you're starting off building a data warehouse, streaming can be over-engineering for it. A lot of times it's easier to build it in batch and try and see if that can work, again, knowing what your end use case is, and then as it evolves and becomes more mature, implement more real-time processing. There's two other things I want to comment on here specifically is ETL and ELT. So this is a common terminology in data engineering world. You may have heard of it before. It stands for extract, transform, load, or extract, load, transform. About maybe 10 years ago or so, ETL was a lot more kind of the standard, extract, transform, load. You pull it out of a source system, you do some transformations while it's in the pipeline. These transformations could be, basic rolling averages. They could be, some sort of data conversion type. They could, take whatever transformation form you want. You could do it in Python. You could do it in any coding language that your pipeline supports. And then you would then load it into your data warehouse. Recently, there's been a lot more of a push to go towards ELT, where you're extracting it and you're loading it without really touching it too much. And then you're transforming it once it's within the warehouse. And that can have a lot of advantages, because if you just make a base replica from where it is at the source without actually transforming anything, you then also are kind of getting further upstream to understand, before you've done any transformations on this data, this is what it looked like at rest before it's entered the data warehouse. And that can be really useful as you're trying to trace through and troubleshoot problems that can isolate, okay, this data quality issue maybe originated directly at the source and it wasn't in the pipeline, because you can see it's already in your staging layer before you've touched it at all. And so there's different approaches you can take there. Again, fluctuate based off the different business cases you're trying to solve. But you generally have the data storage sections at the top, and then the data pipelines moving them between each section with different technologies at the bottom.
Question.
Yes.
So on this diagram, let's say I was interested in doing streaming because I was building a decision support system and I wanted to get real-time results and all that. You're only loading, in this diagram anyway, you're only loading streaming into the staging layer. You're still going to have a batch process to get into your warehouse before you can even report on.
So are you saying, oh, yeah?
Okay, can you repeat the question?
So I'm looking at the
Oh.
diagram here.
For me,
right?
sorry, yeah.
I'm sorry, do you want me to repeat it?
No, I want him on the.
Yeah, for me on the mic here. So if I'm understanding, your question is you're streaming data into your data warehouse and then you're batch processing it from there. You're asking like, why is that?
Well, I'm looking at your diagram here, right? You've got section 1, you've got streaming under section 1, which is really just going to a staging layer, which from the diagram anyway, you're not able to actually report on any of that data as it's not actually moved into the warehouse.
Right. The diagrams, the 1, 2, and 3 are 3 sample ways that data can move. It's not exclusive that you're only going to do batch or streaming from your source to staging, and then from staging to warehouse, you're going to do a different process. You can stream all the way through. You can break it out into sections. Maybe these kind of, it pivots and it flows 2 different routes. You have the streaming into one that you're reporting on real time, and then you also want to do some, longer term analytics on that would have a batch process associated to it. So it's not necessarily this diagram, I'll be honest, I got offline. I didn't make this myself, but it's kind of showing the different examples of what can be used, not that they make sense exactly at these processes in the warehouse flow. Does that make sense? Any other questions?
Just a
Yeah.
generic one. Is this all predicated on the assumption that the architecture is primarily in the cloud?
It doesn't have to be. It can definitely be out of the cloud. It can be hosted on-prem, and I actually have a slide on that a little bit later to talk about kind of some of the pros and cons of doing it each way.
Thank you.
Yeah.
What was
ETTL is, again, from the location that I got this diagram from. I think it's a little less commonly known. I haven't used that. I haven't implemented that myself specifically, but I think it's like a mini transform in the pipeline, and then you do more transforms in the warehouse. It's kind of like a 2-part solution to it, which is why they have the lowercase t for the mini transform and then the uppercase T for the more major transforms. Yeah. So starting off with a little bit about, we were talking how a data warehouse actually, what its function is and the high level architecture for it. Now we'll go into a little bit more details now that we kind of have that foundation of how do you actually pick your tech stack for your data warehouse that you want to build? How do you do proper discovery to understand you're building the right things to accomplish your business goals? What data models or schema design should you implement based off different business models and different business objectives? And then also, how do you kind of move the data from one section to the other, the different batch or streaming processes, and what those can look like? So starting with discovery, this is still a little more high level, but as I was saying, understanding what it is you're trying to achieve before you start building something can be really valuable. And so when you're going through the discovery process, it's important to answer a lot of these questions to understand what it is you're looking to accomplish. First, who are the key stakeholders? What are their goals and objectives from implementing this data warehouse? What business information do they want to be able to act on? And what transformations might they be aware of? They might not have all the answers right now. Some of this is going to be lofty goals. Some of this may be more practical, some small scale stuff. But getting a sense of where their head's at will help you as an engineer or whoever is building this know how to set up some of these later downstream steps because you understand what the end goal is. Also, understanding what the existing systems look like is really helpful. Knowing what level of interoperability you have across these systems, if you're using industry standard, maybe a Salesforce or Google Analytics or NetSuite or any of kind of the big industry players, oftentimes there's a lot of pre-built integrations that might help you get to a solution much faster that you don't have to build custom. If you have a really bespoke niche software that you're working with, you might have harder time finding integrations built for it. Also knowing how clean the data is to start with is really helpful. Do you have 5 different customer lists that need to be consolidated, and in order to kind of look at those data sets in apples to apples structure? Or are there other sorts of quality concerns that you've got a whole big product list and there's not a proper hierarchy structured across your full product book, and that can pose an issue downstream? Knowing what some of those future roadblocks are will help you design around them, and also maybe even start some of that cleanup work that might not be pivotal for you to do in the data warehouse, but that a business user is going to have to actually spend time and manually clean up some of that data. If you can get that train started, make some progress on that, that will help it. So when you then use that data later on, you're doing yourself a favor. How are people going to access this data? We've talked about this a little bit before, but are they using Excel connected sheets? What's the capability of the users? Can they write SQL queries themselves? Are you connecting with other, using APIs to send and receive data programmatically? Or do you need to build some custom reporting solution? Are they looking to just build visualizations and graphs on top of it? All of these things of understanding these better will help figure out what tools make sense. As I mentioned, the people, what is the skill set of those that you're interacting with? What's the skill set of your own team? Do you have the skills you need internally? Do you have to work with external contractors? This also is where I mentioned about bringing in a data expert. When you're getting this initial team together that says, hey, we might want to put together a data warehouse, or we might want to build something, they might have ideas of what makes sense, but some of those might be really achievable and some might be really, high effort, low value propositions, and others could be really low effort, high value propositions. And having somebody with experience building data warehouses helps provide some of that intuition, so they might be able to say that this makes sense, as a first goal, and maybe this one we kick down the line because you're going to need a lot of other, building blocks before you can get to that level. So knowing what that intuition looks like will be really helpful too. And then other is sort of the catch-all. Every organization has different needs. Maybe you work with proprietary, personal identifying information that you have to be really cognizant of. Maybe you're a payment processor, or you're a healthcare platform, and that's important. Or maybe you're a startup that you're building for now, but you also are expecting a 10x revenue growth, and maybe even more than 10x probably data growth in the next year or two. So you got to build with rapid scalability in mind. That's another important thing to know. Kind of thinking of the context that you're operating in is really important to know before you. Hopefully most of this you will know if you're at that organization and you're working on it, but capturing this in the discovery process is key. Yeah.
I should have asked this earlier. How would you describe the difference between the term data warehouse and data lake?
You're beating me to it. I got some slides on that later. Yes. If I don't answer it by the end, though, let me know and we can come back to it. Yeah. So, as I mentioned, you'll have plenty of out-of-the-box solutions that will accomplish what you're looking to do. There's probably already some software that is marketing towards achieving this goal, plug and play, and you just turn on the lights and everything's going to flow. That might make sense for you. Again, it depends on the business problem you're trying to solve here. I'll keep kind of tying it back to that. But in my experience, oftentimes if you're starting if you're in a smaller organization, or if there's a more isolated problem that you're trying to solve, going with something out of the box might be the better route. You don't have to sink all the development time into it. You've got a dedicated support team, and maybe it's just a monthly fee that's the easier option to go with. However, I do also think there's a limit when that starts to become untenable. Over time, if your organization is growing, or ideally the data warehouse is a success and there's more people that are trying to learn and add more data sources to it and build more advanced reporting off of it and kind of continue to evolve it over time, the existing software that you pick most likely doesn't have all of those features and functionalities built into it. Or you might have one software that does one thing really well, and another software that does another thing really well, but they don't necessarily talk to each other. And the more of these individual softwares you have, the more of a problem you start to have with, again, centralization, consistent approach, and awareness of what else is going on in different parts of the organization. Let's see, incomplete. And then, permissioning, version control, these are all other points of concern that are worth considering. So to your earlier question about cloud native versus on-prem, this also has a lot of, the answer to this depends a lot on your organization. And if you already are building everything in AWS, then that's probably the route to go. If you don't have anything in the cloud, then maybe that's not the route to go. If you work in a large organization and you already have dedicated data centers and they can just stand you up an extra environment, a VM to work with, then maybe that's the easier route. But if you are starting with a new data warehouse that you're learning, or you're a little bit earlier on in your process, generally cloud is a lot easier to start with. They have, over the past decade, they've made it so easy now. With the click of a button, you can stand up entire instances, database instances. You have all these pre-built connectors. You have basically infinite scale. So there's a lot of benefits to going cloud. There are some limitations that, if you really want tight security, and you don't want all of your data flowing on their networks, clouds have thought of a way to get around that. You have your own private networks that you can implement in clouds, and so there's an alternative for all of these. But generally speaking, if you're starting with this from scratch, I think cloud is the preferred solution. You've got any AWS, GCP, Azure have environments for this. Snowflake, Databricks, those are really common cloud-hosted data warehouse solutions. You can build it on-prem. A lot of times on-prem is more for like large enterprises where you do have entirely internal managed data centers that you can work with and operate from. But generally speaking, this can be done in either way, but cloud is most likely the easier route to go with nowadays. So now we'll shift a little bit more towards database management systems. So there's two things I kind of want to highlight with respect to the data warehouses. If you recall back to the earlier section about you've got the layers and then you've got the movement. So we'll talk about the different databases, generally relational database and NoSQL databases, and what some of those pros and cons are of those different options, and then some of the data movement and data modeling. And those will kind of be the two sort of deeper dives we'll do into the data warehouse, and then we'll wrap up with some case studies after that. But I kind of breeze through this a little bit quicker, because with most of you that have some experience into it, I don't need to break out a database specifically in a lot of detail. There's hardware that it runs on. There's software that actually makes the database work. There's stored procedures for login and installation packages, things like that. There's the data that it stores, and then there's a language used to query it. That at a high level is what comprises a database management system. So if we now look at relational databases, maybe by a show of hands, how many of you worked with relational databases before? Okay, so I won't go into much detail on this. It seems like we're pretty well versed. You've got conceptual models, logical models, and physical models. This is sort of the evolution of, from this idea, working with a conceptual model, you make it a little more realistic as you start to work through a logical model, and then your physical model is a lot more representative of the actual implementation in the system that you're working with. And you can see the different components that are contained in these as you evolve. NoSQL databases are an alternative to relational database. These are kind of four key examples here that this one's a little cut off down here. But you've got key value stores. So this you can think of as really fast, simple. You oftentimes use for caching, things like Redis, where you can, common analogy that I really like is think of it as like lockers. So instead of relational databases where you've got to go look up on every individual table, you can quickly find the locker you're looking for, and then everything that's within that locker is at your disposal, but you don't necessarily have connections across all the different lockers very easily. And so for certain applications, key values make a lot of sense, such as caching. Document databases, where you've got XML or JSON documents all stored with different indexes, lookup, very fast retrieval there. Wide column is where you can look at it individually on rows or on columns. It's kind of double indexed in a way, and it's really optimized for different read and write processes. Some databases, like analytic databases that operate at scale, that kind of implement some element of wide column in the back end, but generally speaking, this is optimized for your read and write processes. And then graph is the final NoSQL database type for a lot more relationship type of data. You've got nodes, you've got relationships between those nodes, you've got properties, edges, things like that might not be as relevant for a flat structure, but more of kind of relationship oriented. And you can see a couple of different common databases. Most of these you might have heard of before in some fashion. Okay, so now I want to pop over and do just a quick demo in data form. So the first portion of that was really focusing on the data structure or the data storage, and now we'll talk about the data movement. If you guys have used DBT, or has anybody used Dataform specifically, which is GCP's version of that? Yeah, one. Has anybody used DBT? Couple. Okay, cool. So this might be a little bit more new for some folks, which is great. So let me pull this up here. Okay. Oh, that is really zoomed in. There we go. Okay, so I'll start with the data tables. So this example is all working with a public data set in BigQuery called the Look e-commerce. This is just sample sales data, manufacturing data, orders, users, products, things that would be very common for an organization to have, but it's just they're publicly available to start with. So you can see we've got a couple tables here that we'll work with. You've got orders, which we're looking at here. You've got, and these have order IDs, user IDs. You've got products with the ID of the product, cost, category, name. So you can see there's a couple different dimensions on all of these. Maybe I should have mentioned this a little bit earlier. Dimensions, you look at a table, you've got all kind of the categorical information, the metadata associated with it. So things that you can't numerically aggregate, like names or colors or emails, stuff like that. And then you've got facts, which are numerical data. So these can be, sale prices, quantities, dates, things like that you can, do aggregations and sums and max and mins and things like that on top of. So we've got a couple different data sets here to work with. And what I want to show about here in data form. So if you're not familiar with the UI, this is basically your file structure on the left-hand side here. And what data form is an ability to build data models directly on top of utilizing SQL, and then having a lot of overhead, orchestration, relationship, data validation, functionality on top of it. So if you've written SQL queries before, you probably know that most of what we're doing here can just be transformed into a SQL query. And that, again, might be the good starting point. But eventually you'll reach a scale where you can no longer just write a bunch of SQL queries or schedule these to execute on regular intervals, and it will become untenable of trying to keep track of all of this. So that's when a tool like Dataform or DBT comes into play, because you can add a lot of attributes that extends the functionality. So walking you through what we've got here, we've got a couple files here at the source in a source directory, and you'll notice that these are just a declaration. This is Dataform logic, but every Dataform syntax, but each software has its own version of it. And you can see this is just a declaration. So it's saying that if we think back to the data warehouse model we had, this is our source data. This could live in your database. It could be an authorized view from another database. This is basically saying the start of the pipeline. This is where the data is originating from. You define this as a source. We've got this for each product's user. One other thing that I like about Dataform specifically is these are called SQLX files, which is again the other ones you'll see it's really SQL based, but they also support JavaScript. So you can insert JavaScript into your SQL models at different points wherever you want, and that really extends the functionality of it quite substantially. So here is just another alternative syntax for defining a source model here. So these are the starting points. You can think of these as the tables that we were just looking at. And then as you move to the next stage, you've got your core models. So you want to operate on top of these. You might want to do some basic transformations. You might want to establish some joins, some assertions. So a couple things to point out here. This right now is built as a table. When we execute this workflow, you'll see that this table actually gets created in BigQuery, and then it can operate on downstream from there. You could build this as a view. You can build this as an incremental table where you can specifically define what you want your upstart logic to be based off of. So you might have any data that, say, Google Analytics data, right? You're getting millions of records. You've got a lot of visitors to your site. You don't want to have to rebuild the entire table from scratch every day, so you make it as an incremental table. So instead of rebuilding everything, you're just querying the past 3 days that you might have a partition around, and then you're only updating based off those days. So it just makes it a lot more performant. You're not having to rescan the whole database every single time. So that's just alternative types you can define here. As you recall in the source, that was a type of declaration. You specify your schema that it's in. Here you can list out columns in the description. So in this case, like this was still from the test, but you could say, what is this? The product ID. You could add another column description here of cost of product. I mean, you can, But the nice thing about this is because this is really well integrated with BigQuery directly, all your definitions that are listed here will all copy over to the table itself. So when we actually look at the table that gets created, each column ID has its associated description tied to it. Then you got your SQL model. One thing to point out, and this is just a basic SQL model, you can tell. One thing I want to point out here is the reference down here at the bottom. So this is a huge value for using a tool like dbt or Dataform, is that you're dynamically producing the relationship. So here we're just defining it's coming from a schema and a name of the table. But you can see here when you look at what it compiles to, it's actually querying that public data set there. And so what this allows you to do is you can chain different models together. So this would be, you're building a products model, you've got a users model here. And then if we look at, say, orders lines, here you're doing a join across two different models, but you can see they both compile to their respective tables. And so when we then look at this, before we do that real quick, we'll look one more at, so you've got your core model, you got your source, your core, and then your data marts. And the data marts is what we're including in here. This is really your consumption optimized structure. And here, for example, we've just combined order lines, products, users into a basic table. But if we look at these refs down here, these dynamic references, when we see what they compile to, you can see ecosignifier. This is the name of the project that I'm in right now, just as a sample Google project. But they're now pulling from these other core models that were built here. And so when we go and we look at how this compiles, you can look at a compilation graph, and you can see that orders flows into this core table of orders headers. It also flows into order lines. Product declaration flows to the product core model, which flows to this orders analytics data mart table. And so you can really start to see the relationships, which, again, we've got 4 tables here as an example. When you get hundreds of tables, having a visual layout is really helpful. And one more benefit of this, too, is that when I'm trying to run models, and by run models, I mean I want to recreate this, right? So if we go to BigQuery here, I wish this was replicated down at the bottom, and we go to the data sets that we're using. So here there's a data mart schema, and we had a table in it just because I was running it before, but now you can see that this data mart schema is empty. There's nothing here. When we go to Dataform, we can now run this model. If we do start execution, we can select this model specifically. And what this will do is it will handle creating this table entirely for you on the back end. So you're just defining the SQL model itself. But if we go then look at the execution that was created, you can see here this was timestamp at 6:51, and you'll see it adds, this is what Dataform adds, or dbt, any tool you use is going to add a bunch of other logic above and below your query basically. And what you can tell is it's creating or replacing this table based off the name that you provided. And it defines, here's your model that we defined specifically for. You can see it uses the compile dynamic references. And so now when we go back to BigQuery, this was empty, and now it's listed there. And you can see these don't have any descriptions associated to them because we didn't add a description when we were making this model here. So there's none here in the config block. But now that we've got this model, what I also want to highlight is when you're doing another benefit of dynamic references is we were just running that one model. But say you've got 15 different tables or different models that are all chained together, and you want to be able to run them or you're fixing one, and you don't remember exactly every other table that it touches. The compilation graph, as you saw, does know that. So it's very easy with the click of a button. You can include everything upstream, or you can include by dependence everything downstream. And this will automatically rerun every model that's associated to it. So if we now run this execution, whereas in the first time, you can see that we had this one model that got ran. Now, when we look at the most recent one, you'll see it's not just running this order analytics table, which is the one we selected. It's also running users, products, and order lines, because all of those are dependents of that model. And so it makes it a lot easier to kind of keep all of this in check and maintain it across the different systems. And this should be done. And now, because we reran that model, we also had updated previously, which one had that ID, the definition? Product. So we added in this cost of product. So now in theory, we go to here, we should see, now in the description, you can see cost of product is already being maintained. So the other big benefit of this is, as you can tell, this is all just SQL and some JavaScript code. So you can connect this to Bitbucket or GitHub. You can implement version control and all this. You can create PRs. You see here on the left, you can start to see commit changes. It's tracking all your changes like a normal diff would have here. You add commit messages. You connect to any remote repository, so you get a lot more version control implemented on top of it, and it can start to integrate with more traditional software development practices. One other thing I want to point out here that's another big benefit of a model such as these is the assertions block at the top. This is how you can implement data quality. Certain databases, as you guys know, you've worked with relational databases, you can have primary keys, foreign keys defined. You can implement some level of constraints. Not every database necessarily has that. BigQuery in this case, which this operates on top of, doesn't have those defined in the database itself, but you can define these in the models. So here you can see this is listed as an assertion. You're specifying that this field of item ID is non-null and it's unique. In this one, I think you have, there's another row condition where you can specify kind of a little more complex logic that this is basically any parsable SQL you can include as a row condition here. So you can use, email like, wildcard @wildcard to enforce emails to be rendered properly. And the nice thing about this is when you can enforce that all of these are true, if I then change this row condition and I say, actually, for when I create this model, I want you to make sure that the number of items, which is coming from orders, doesn't match the count of the items that are joined on that, which is kind of the opposite of the truth here, but you can tell how it worked before. It executed properly. Now if I run this model, well, I'll just run all actions. So it's another, kind of a shortcut where if you've got a lot of models, there's a lot of different ways you can work with this. But this should, in theory, produce an error because the individual assertion failed. So the model itself, you can see, rebuilds properly. It doesn't kind of cause a break in your entire pipeline, but now you can see that this assertion fails. You can open up specifically what the failing records are. And if you want to dig into the details of it, you can see exactly the SQL that ran that produced it. But this should produce a view that you can query, and it's going to be basically all of them because I made it anti-truth. But you can see that it tells you the failing row condition, and it tells you all this identifying information around it. You can build notifications off of this. You can send Slack messages, emails, whatever sort of alerting you want on different levels of assertions. So it just gives you a lot more greater control of the quality of the pipelines that you're working with. So that way, when you deliver this to business users at the end of the day, you can be confident that all the rules you set up are being implemented properly, because otherwise they would produce errors.
So assertion is the check, it's not transformation, right?
Correct. They'll operate on top of the models rather than kind of like in the critical path. And those are also shown here too in the compilation. So you can see they're dependent on the specific model. So the one we just changed, which one was it? Was it order headers assertion? So it was, this one here, which you can see the query that it's running specifically. And so again, if you wanted to run just upstream or downstream, or if you remade this model, it would know only let's run the assertions that are related to that model rather than the assertions across the whole platform. And you can set up different deployment schedules for these. We don't have any of this set up yet because this is just a sample project, but there's different releases and schedulings that you can create a development releases, you can production, you can have numerous different environments. Certain environments only run certain models on different schedules. You can change permissioning for each environment. You can separate them across different projects. You can have them all within one project. There's a lot of customizations. You can kind of take this to the umpteenth degree, depending on what your need is. But it shows you a lot of the functionality just kind of out of the box, which you could get this set up with in 5-10 minutes or so on their free tier. Yeah.
So through your experience with GCP in production, have you all used this orchestration versus like an Airflow to run these models on one schedule?
Yeah, we have used these. We've also used Airflow as well. I think they solve different use cases in my mind a little bit. I think Dataform is really good when you are not as focused on I'm gonna always what's that word? Idempotency. Thank you. I can write it out, but I can't ever say it. Idempotency. If you have to rerun a lot of these, you can configure Dataform so it only runs the necessary models, but it takes a little bit extra work. Where I know Airflow, you can just it handles a lot of that automatically within the DAG. So they're similar, but I think Airflow is better when you start to get to more shorter update, shorter refresh frequencies, and for Dataform in particular, I think it's optimized if you really are already using BigQuery and you're already in the GCP ecosystem. You can use their Composer, which is their version of it, but personally, I've had more experience with Dataform, so I've been able to kind of work it into most of my use cases that I've come across so far. Yeah, good question though. Yeah.
So when you're working with multiple different types of data stores, like let's say you have a NoSQL, you have some SQL, maybe you have some macro files and S3, and you're ingesting all that, do you typically put all of that in its native format into the warehouse, or do you like transform that into like a tabular format and the data warehouse is just tables?
I think ultimately it depends on what you're trying to do with it and what some of there's inherent constraints there as well. I think it's probably not optimal to shove data that's not meant in a relational database into a relational database. If you've got something that's optimized for a NoSQL database, I think it's probably best to keep it in that structure because you're going to get a lot of performance constraints and decreases when you do try and kind of push it into a structure that it's not optimized for. So, but maybe there is a use case, and that probably gets to a slide a little bit later on about a data lake, where it's not, data warehouse is traditionally with more structured, mostly structured, maybe a little bit of semi-structured data, but if you're working with truly unstructured data or stuff that is less structured, like more heavily semi-structured, then you probably want to use a data lake or a lake house or some other kind of alternatives that are not where I in my mind at least I think of data warehouses as a lot more traditionally structured data sets. That's a good question though. Anything else?
Pricing?
Sorry?
Pricing?
Pricing?
Yeah.
Yeah, so with Dataform specifically, or just in general?
Generally, like, I guess, these tools grow like mushrooms, right? And I think that's one of the things that you have to always consider, whether or not to pick one or another. It's like with DBT, there's a free version, but there's also enterprise and cloud. With Dataform, I guess, what is the price considerations?
Yeah, so Dataform itself doesn't actually cost anything to use. It's offered for free within the GCP ecosystem. Granted, it only operates on BigQuery, and it integrates really nicely with all of the other GCP products. So if you're already working on a GCP project and you're in their ecosystem, it's very easy to stand up. You only pay for the compute and the storage that you use on BigQuery. So BigQuery charges based off of compute and based off of storage separately, and it is, BigQuery, at least in particular, is very cheap for analytics size data analysis and data storage. So I think it's pretty cost effective when you start to hit certain scales. But there are other ways obviously you optimize Dataform so that you are not unnecessarily utilizing compute. You're not rebuilding it. Like the incremental table is a perfect example there. Depending on how you set this up, your Dataform project could cost $1,000 a month, or it could cost $15,000 a month if you're unnecessarily doing compute on top of it. But Dataform itself doesn't have any extra cost.
Question.
Yeah.
So you put up a ref function in one of your SQL statements. and then there was code that popped up on the side that looked like a Proc SQL or something like that. Are you having to write that yourself as a dev team, or are you able to like set up like a YAML file, or you create your sources to your target, and like DBT, you use unit ref functions to do that?
So are you talking about this on the left or versus compiled on the right?
So after you compiled, it said like begin.
Oh. These specifically, right?
Yeah.
Yeah. So this is all created by Dataform, and what determines what logic you have in here is defined by generally by your config block here. So what the structure would look like for a table is going to be different. Like if I just went ahead and changed this to view, then that would tell Dataform when it does all this, it wouldn't do create or replace table, it would do create or replace view. Also, if you have, for example, the incremental table, you're defining the merge conditions for your upsert. They handle all of that based off the table you have specifically and how you're running this. All of this gets compiled automatically. Also, when you run a model, you can run it as we just did. I'll show you like on this example here. There's an option to run with the full refresh. So if it's a base table model like the ones we've worked with here, it doesn't do any different if you're running it as a full refresh or not, because it's going to create the whole table from scratch again. That's just kind of optimized for how BigQuery works specifically. If you do have an incremental model, though, say you have whatever, 1 billion records of a bunch of historical data, and you're incrementally updating it, a bit at a time, then you don't want to have to refresh the whole thing unless there's an extenuating circumstance that you want to go back and repopulate all the records for one reason or another. Then you would run this as a refresh. But what is included in all of this compiled query is if I were to go ahead and change like name as product name, what this will do when I go ahead and run this model is it will also, actually I don't need anything else, rebuild, kind of resnap the table structure to what you've defined it as. So you're really like the tables that are underpinning all of this, all of these operations are governed by the code that you're including here in your repository. And so that's what all of the compiled logic does for you here. Let's see. So we're on product. So now if we see there's name here, that should change to product name without having to run any, alter table, modify column. If you change the data type, if I cast that as a string as an integer or vice versa, then it will automatically go ahead and update it. And if there's an issue with it, like that's where the refresh comes into play. If I change a data type around, say from a string to an integer, and I don't run as a full refresh and there's some incompatibility, you'll get an error produced, and then you have to go and you can either run as a full refresh or do it yourself. Yeah?
Will it automatically update all views built off of that table if you change one column name in the table?
So BigQuery, it depends on how you build the view. That is some native functionality with BigQuery if it's a materialized view or if it's a regular view. They have some automatic processes that go in the background that can dynamically update references to views. I haven't tested it myself specifically with Dataform and how that interacts. If you have another Dataform model that you're defining as a downstream dependent from that model, like you have a config where it's not a table type but it's a view type, because you can define views in there as well, then you will need to manually change it because it's going to try and rebuild a view referencing an incorrect column name. Yeah, but if it's built just directly in BigQuery, not through Dataform actually, then I think it will update a lot of those more dynamically than Dataform, because it's going to try and snap it back to your model, which is now out of shape with what's currently in reality. Yeah.
So it's the changes that you're making here, these are being like synced back to BigQuery, right? It's turning into tables. How is the data then flowing? Number one, is this also like what is moving data between those views? Is this like a batch process that you would run, or like how would you do that? And the second question I have is like if you were to create another view, how would you do the naming schemes here? Is that something that you do start v1, v2 in the names or something, or is there a separate versioning mechanism for these if you were to make any changes to these data models?
That's a good question. So the first one was about what actually is executing these on a regular cadence, or how these are reflected in BigQuery. I think there's two things here. One is the release. So this is, again, you can see if you're connected to a Git repository. In this case, it's just hosted directly from BigQuery because I set this up quickly. But if we do, say we want to run this every, 15 minutes or so. And then we just create this. So this is where you can see, this is pulling a release configuration. So it's, if in theory, when you have this connected to a remote repository, Bitbucket, Git, you could specify the branch that you want to pull in. So you can pull in different branches. You can specify how often you want to pull it in. So this would be at every 15th minute. You can see it hasn't been run yet. And then based off of the release configuration, this is really kind of where you define your environment, right? You'd have one for production, maybe dev, staging, UAT, whatever you need. And then you can build a workflow configuration. And this is, you would pull in the release configuration. So you're specifying kind of what branch, what environment you want to be in. You specify what service account you want it to be run with. And here's where you can select your actions. You can do if it's, it's on demand, or you can have it repeat on a regular cron job. And you can, here you specify specifically which actions you want to pull in. So it's not populating here yet because the production release configuration doesn't have models yet, just because it hasn't executed. But this would be what you see in this list here. If you notice the layout, will be the exact same that you can do manually here, where you can select here all your whatever models you want. You can select a subset of them. You can select assertions, or say I've got all of these culminate to one final table. So I just want to select that one ordered analytics, and then as shorthand, I want to say run everything else dependent, everything upstream of that basically. And that's what you could do on a regular schedule. And that will, this is again, Dataform's kind of like the layer on top of BigQuery. So then when you go to BigQuery, this is kind of this is the real-time representation of what your Dataform, Dataform is the same way if I went and copied those compiled queries that create or replace, and I was just going to manually run those every 15 minutes and all of that, BigQuery would look the exact same. It just takes all that orchestration off your plate. Did that answer the question? Or no?
Yeah, so I guess it copies the structure and the data back into BigQuery, right? Whenever you run this. So like the source, you're doing something with the source, and then creating new models on top of those sources, right? So you already have like a big table filled up. You're doing, creating a specific view or model on top of that, moving that data over. That's what I'm getting. Maybe I'm not getting this right, but that's.
No, I think you are right. And that kind of gets to your second point about different versions, right? Like how does it evolve over time?
Right.
So this whole time we haven't touched the source data at all, right? That's coming from Google's public data set. You're not even allowed to change it. We then have made a model on top of that in our core here, and then we've made another one in the data mart. So you could have a data mart for manufacturing. You could have a data mart for finance. You could have a data mart for your engineering team. And you could then, in each of those, so we can do that just kind of real quickly here. If we were to do, let's just copy this base one here. Oh, that's not what I want to copy. And make another file, and we'll call this Orders Analytics Limited. And then we're going to say we don't want, this is only a limited selection of this. So instead of everything, let's pull in, what's a field we can filter on? We'll say North Face, right? We got a North Face team and they only care about North Face data. So we can add an aware clause here. This is brand, which is coming from products, dot brand. We'll just do equals the North Face. So now you'll see, oh, I gotta spell it right. Here on the right-hand side, this compiled query will just include that where clause.
Product, not products.
Oh, thank you. Wait. Oh, the alias is it not called brand? Name not found inside products. Oh, it's no longer called name because we changed it. So this is to your earlier question. Now this is called, what was it? Product name. That's right. So this is a part where data form, because it's going to try and force it to be name, it'll tell you that ahead of time. If you tried to run it, it would have also given you the same error, but it just kind of saves you the trouble of clicking between tabs. So now that we've got this, we can run this model here for our North Face team specifically, and this will produce another table here, which could, again, be in its own schema if you wanted. That's Analytics Limited, and you can see this is only 240 records, and all of these should have a brand of the North Face. So here's kind of where you can section out. You could do this across different data marts, all in the same project. You could do this on different table names. I mean, this is where it's flexible based off your business needs. If you want to have hundreds of tables all in one schema, and you want to define them based off the naming convention of the table, go for it. If you want to do it all across different schemas, you have flexibility in terms of how you want to implement it. But it gives you the functionality to do that. Yeah. Or,
Go ahead. Take that.
sorry.
Oh, sure.
New question.
Yeah, I guess the question I have is like, how do you delete data from a data warehouse? Like, for example, there's PII data. You have like a GDPR request to delete it. Would you like delete it from the source table and rerun the models, or like, how do you handle that request?
A couple different ways you could do it depending on what the request is. This is kind of another reason why it's beneficial to be in the cloud, because most of the use cases you're going to come across have somebody else has had that problem before, and so most likely they have some offering to solve that. Google in particular has their own kind of PII obfuscation technology where you can store it directly in their databases, and it will handle it like it'll store it encrypted basically. You can use one of their encryptions. You can implement your own custom encryption key if you don't want that to be based off of their encryption, and you want to kind of get to a level of security higher than that. So you can keep that directly in the database. If you do so that would be kind of for data that you have to operate on, but you still need to store. If you get, say, a request to delete somebody's data entirely, and that's a common request you get, you probably would build a process around that would identify the relevant tables, hopefully dynamically based off of where that data is stored, and then you would have some process that you'd probably have to write custom to make sure that you're going and deleting it across those. BigQuery also has some functionality on like time travel that I think is really useful, because if you've worked with a database, you've most likely dropped a table that you didn't mean to, or changed data that you only realized after you've executed is not what you meant to do. You can, native with BigQuery, it comes with 7 days look back. So you can basically query a table at any time in the past 7 days and retrieve exactly what the table looked like at that point in time. So there's probably some additional steps you have to take to erase it from the look back period as well. I haven't gone all that down that rabbit hole, but there's different kind of custom or maybe out of the box solutions depending on how fancy of a data security need you got to work with. Yeah, good question though. Yeah.
I was going to ask, like, in your diagram that we saw before, if you were to fit these BigQuery and data form, where those pieces would lie. If you go back to the diagram, or whenever you get back to the presentation, I guess.
Yeah, if you're talking about. Also, the first time I'm using this Gamma platform. I don't know if anybody's used this before, but it's like an alternative PowerPoint solution, and I'm new to it, so bear with me here. But you talking about this one?
Yeah.
So, data form itself, I would consider more of the data transformation pipelines down here, because this is control. It's governing how data is being transformed and moved from one model to the next. This is data form execution is taking it from, well, not from here. It's taking it from 1 to 2 or 2 to 3, and you can think of these kind of different schemas. BigQuery, which is where the data resides, that underlies, the data form operates on top of, is the database itself. That's the storage component, and then the data form is the movement component. Yeah.
So I think let's say if we have a source layer of graph data types, but it should be in terabytes, multiple sources, and we need to index them, and then we also need to apply combines on each item, each record that we transform. Should we do on step 2 or step 3? Where should we do I'm talking about if somebody's trying to build queue service or
Query service, you said?
yeah,
Yeah.
queue
Okay.
service, and we need to wrap that up on maybe a API layer, something. So in the data will be coming from the blockchain side, and then we produce data maybe every maybe 5 minutes or 10 minutes, or sometimes it's more frequent. So we have to do a lot of indexing. And so how should we do that? And we also need to be cognizant of compliance side.
So I think it depends. That the answer to that depends a lot on, well, one, do you already have an existing data warehouse that you're operating within, or if you're building it from scratch? The staging layer and the warehouse layer and the consumption layer are more ideologies that you generally have a starting point, maybe a middle layer, and some sort of ending. It doesn't necessarily have to it doesn't have to be 3. It could be 5 layers if you want, potentially. And depending on what other components interact with that process as you described, where you have to have it obscured at a certain level. Maybe you need a process before that. If you need nothing before that, and it should be obscured at the very beginning of the pipeline due to some compliance reasons, then it's probably good to set it as early as you can. If you don't need it obscured until later on and you only want it obscured right before you send it to an API endpoint, then you do it later on in the process. There's not a right or wrong way to do it, really. It just kind of depends on what the other pieces that it's operating around are, and how you can set it up to be optimized for that specifically. So it's hard to say in the abstract about if it should be from staging to warehouse or warehouse to consumption. It would probably depend on what the business use case is around. Why does it need to be obscured? Who has access at each stage along the way? Can be visible to people internally. And then also, if you're working, like you say, with large scale graph databases, are those more compliant or more compatible with certain stages of your pipeline and less compatible with others, then it's probably the better spot to insert them into the areas that make the most sense. But I don't know exactly off the top of my head, like in the abstract. It would kind of depend on the application.
So in the case of GDPR, PCI compliance, in your experience, normally you do it on stage 1 or stage 3 or stage 4? And where do you do that? Before transformation, after transformation, where do you do it?
So for something like GDPR, that's the only one I've worked with in the past. A lot of that, in my experience, has been taking it from across regions, and you're not allowed to transfer data actually outside of the country that it's collected in. And so in that case, it doesn't apply so much from one stage to the next, because in theory, your whole data warehouse that stores that data has to be on location. So in that case, you would set your whole GCP project up directly in that one with that based off that location, and your whole warehouse would operate within that. As far as my understanding of it, you're not really allowed to take that data across somewhere else. So if that is where you're operating, and you have, say, 5 different business units that are all operating on different countries, and you can't cross the data, then that has, it's kind of unique. That would be in the other category, where you have to build your data warehouse around that, and probably come up with a way where you can replicate the same structure independently of each other, with maybe a third-party governing software of some sort that you only have to update the model in one. But if all your systems are identical, then it can then push down those updates across all the 5. But you can't really bring the data to a different location due to GDPR constraints in general, from my understanding of it.
So it sounds like we're hinting around data governance, things like GDPR. How does that factor in? Like the example of PII data is, one way I've dealt with PII data is have a policy where you say we're not going to let data in. So any PII data in, so use something like Google's data loss prevention API to make sure it doesn't get in. And if it does get in, use BigQuery's API with data loss prevention to make sure it gets redacted. How can you scale that? Because coming up with all these policies one after the other, how does data governance scale in a data warehouse?
It's a good question. In the PII example in particular, if you don't really want to have that in your data warehouse at all, that would be a good scenario where you want to use ETL, where you would in the transformation process, hopefully you would parse that out so you don't ever load it into your data warehouse if you don't want to have it at all. So that would be part of the pipeline rather so much than the storage component. But data governance as a whole for the data warehouse, that depends a lot on what your data warehouse tools are. If you're building it in GCP, if you're building it in Snowflake, a lot of these cloud platforms have data governance tools specifically for them. I know with Google, there's I think it's data mesh or data fabric, and some of these other ways where you can. It really comes into play when you're starting to work with more mature data warehouses that have multiple teams all interfacing with it, and you want to have certain standards across them, and a lot more of like kind of federated permissioning systems. And you can build all that from scratch. It's a lot more work. A lot of these platforms have something that's a little more plug and play where you can pick from a variety of set of policies, and you would say that certain teams only can access certain data sets, or you would have discoverability more like turned on for certain groups and off for others, and you can kind of limit that a lot through a permissioning system, or for governance if you want to enforce standards, you could do that through data quality checks, assertions if you want it along the way. If it can be caught in pipeline, if it has to be caught before it's inserted, then you probably want to put that into your transformation process. Good questions, though. Anything else? Well, we've got a couple more here, but we're kind of at time here, so I don't want to go too long. Maybe I can just breeze through these last ones, or what do you think?
What do you guys think? You guys want to stay 10 more minutes and breeze through these? All right.
Okay, I'll get you out of here soon. I won't keep you too much longer, I promise. I got to click through all of these again. So we already touched on a lot of this. Actually, I'll probably skip over this one entirely. Security and compliance, we talked about encryption, access control, GDPR, HIPAA, PCI, things like that. Exactly, we already covered. This is one thing I did want to mention about what I call, I coined this myself, it's not official, the data warehouse flywheel. This is something that I've seen happen numerous times in my career, where you start with nothing and you've got an idea, you do some initial discovery work, you understand, okay, I have a vision for data warehouse, I have some use cases that I'm intending to accomplish with this, and you start building something. You build maybe kind of an MVP of sorts, you stand something up in the cloud in a couple days or a couple weeks, whatever it is, you build a base report functionality on top of it, and then the flywheel starts to really kick into play, where you build a report that users are then utilizing. Hopefully it brings value to them. They start to recognize if it's used for across multiple users, they want the data to be correct, because if I'm sharing a finance report, if I'm the finance team and other people are using this to make decisions, I want to be sure that what I've said each department has spent is accurate. And so then they want to start owning it because the data is now available and being used by people, and they want to make sure it's correct. So they then own it. As people start using reports more often, they'll uncover more data quality issues, which ideally can then be corrected back at the source. So if you had, as we mentioned earlier, a bunch of different customer names, all of a sudden that report's no longer useful to people because there's no compatibility across different systems. And so then people will start to clean those up. And as soon as a misspelling or a fat finger enters the system, it breaks somebody's report. And so then the team that uses that report is mad, and they go back to the business unit that owns the data management. And all of a sudden, you've absolved yourself of responsibility, and it's cleaning itself up for you. And then they bring you in because they say, okay, we built this base report, but now we want to add more functionality on top of it. Or this report has started to spur more questions that we didn't really think to ask until we had the level of granularity that you've now provided. So then you build out more reporting and you scale on top of this, which extends the reach of the reports, which gets more people to own it. And it's just kind of this cyclical process that can make organization a lot more data-driven and data mature pretty quickly, because I've seen it happen a number of times. And it's just kind of cool to see it start to spin without you even getting involved. I mean, yeah, you as an engineer might be building more functionality behind it, but the base reporting that's there is going to improve itself over time if it's done well. So this is just kind of a concept I wanted to mention that I think is really valuable once you start building something from scratch or enhancing what's already there. Here's just a quick note on kind of that flywheel evolution, some of the steps along the way that I was just describing in brief, and then some kind of practical examples that I've seen in my own career on how these actually take place. So you first start out where you don't have much reporting. Maybe you can't calculate it from the source system that you're expecting it to. This salesperson sold you this shiny little tool, and now all of a sudden you're trying to use it in a way that it slightly wasn't intended for, and they're like, hey, that's on the roadmap, but that's a year out. So, until then, sit and wait. So that's kind of the impetus where you're like, okay, well, we can do this on ourselves. So then you might use a third-party tool like Fivetran, for example, if you want to use a very quick extract and load. It's got hundreds of connectors out there. You just plug it into one, and then you can dump it into Postgres, into BigQuery, into Snowflake, into pretty much any receiving system, and boom, you've already completed your extraction layer, your ingestion. You don't have to build anything. It's kind of point and click. You can build custom on top of it if you want, but you don't need to if you're just getting started. You build up some data models based off of how the business's needs are structured. You do some standardizations. You look at currency conversions, date periods, whatever it is, and then you give this access to people to use. And they've got data access. You have proper permission set up. You can do it as quick as easy. Again, if you're in the Google system, as a Google Sheet. That connects natively to BigQuery. You write a select star from this table, and boom, you've got permissioned reporting that's in a format that the users know how to use, just like Excel, Google Sheets. They play with it. And that's kind of the baseline there. That's the start of the flywheel where, okay, now you've got a closed loop, essentially, where users will use it and can go back and correct the system. Then all the other stuff from there is just kind of the icing on top of the cake. This is where it can evolve to over time. There's a lot more you can combine disparate sources. This, I think, is a huge value of data warehouses, where you might have tools that operate great in their own ecosystems, but you don't have a way to look at data across systems. So you might have, accounting's got their finance data, but you don't have that tied back to the manufacturing to produce a true cost of goods sold. And you don't want to then have that tied to salespeople because that's in a different system. And so you don't know who's sold or what product breakdown. And this product hierarchy exists in one system, but not another. So when you can start combining across different systems, that gives you a lot of access and a lot of insights that frankly aren't achievable without a data warehouse or a heavily manual process by somebody exporting it from all these and doing that on a repeated basis. The reporting expands because you have more data in there. You can set up automated notifications, resource monitoring, email out reports. I mean, this still isn't super advanced functionality, but it provides a lot of value to businesses if it's something that didn't exist there previously. You then enrich it even further, not just combining disparate sources, but adding third-party data or trying to add in customer segmentation or other sorts of kind of advanced analytics on top of that might provide extra value. And then the last step is you've got a more mature data warehouse, you can hopefully scale that by building a community if you're in an organization with other people that are interested. Getting to the earlier question about governance and standards, you can set some protocols in place, you can publish documentation, you can hopefully get other developers to contribute and add on to it based off of how you've set it up properly. So that way this can kind of really scale beyond just you as an individual and start to make it a kind of an organizational-wide impact. And this is valuable on all sorts of scales. There's large, I've done it at $8 billion organizations, as well as small startups with a couple hundred or 100 or so employees. Different scenarios, different maturity levels require different needs, as we talked about earlier, but it's applicable at all sizes. These I won't spend too much time on. I just kind of wanted to highlight them. If anybody has particular questions, we can try and talk about it. I don't have expertise in some of these, but ML models is something everybody's heard about. The data warehouse kind of underpins all the functionality of that. You've heard crappy data in, crappy data out. If you don't have high quality data to work with to build your model on top of, then your model's probably not going to be as effective as it could. So having strong foundation is huge for successful ML models. Different multi-cloud hybrid deployments across different ecosystems for large organizations. Data fabric, data mesh we already spoke about. Lake houses is kind of what we're getting at a little bit earlier by mixed structured, semi-structured, unstructured data, depending on what it is you're working with. Some of those architectures might make more sense. Natural language interfaces or kind of NLP. You can do semantic search. This is kind of just fancier ways of creating SQL queries that you can layer on top of it. Cost optimization and FinOps, trying to have more cost transparency is a big thing now. Trying to minimize your impact and sustainability focus by if you try to optimize certain queries. There's a lot of ways you can kind of take this to, again, the umpteenth degree and really mature it if you so desire, depending on the maturity level. But just other things that are out there. And then lastly, this is your question in the beginning about data warehouse, data lake, data mesh. I won't go into all of this because I know we're kind of at time here, but you can see there's different types of data sources, different structures. What I described is just one example of how you can set up a data warehouse, but why I was trying to harp in the beginning of the discovery is it's not a one size fits all. You really have to set up an architecture and an approach that makes sense for the problems you're trying to solve. And so you can see here, there's a number of different ways you can do it. different databases in different locations, different database types, different transformations, different data sources. All of that makes sense in different ways. And this is really where having a data expert early on in the process gives you a lot of value, because if you can start setting up the right path, you can save a lot of headache later on if you get halfway down and you realize, oh, actually, this isn't really what we needed because we're running into some critical blocker that we can't get around. So there's a lot of different ways to do this, tons of resources online. I'd be happy to link out to some more if people are curious about specifics. Key takeaways: figure out where you're at, figure out where you want to go, building something quick and dirty just to get it off the ground and start the flywheel, and then keep making it better from there, trying to grow and trying to make it more successful. And that's it. I have it's a QR code for my LinkedIn. Just selfish plug. I'd like to connect with you guys. If you have any other questions, I'll probably be sharing out some resources, some slides from here. I can send you the slide deck if you're curious about that. There's also a case study that I'm putting together now at my current organization of the most recent data warehouse that we built that I'll be sharing on LinkedIn about how we implemented this at a large moderate-sized organization and some of the specific needs that we were trying to solve at their company. So that's coming as well. You've got my email. Again, I'm working at Insomniac Design, so if you have any questions about that or what they do, feel free to reach out to me. And I appreciate your guys' attention today, and hopefully it was useful. Yeah.
You talk a lot about BigQuery, but do you have any customers that maybe they want something that's not vendor lock-in? They don't want open source alternatives. Not necessarily even open source, but just something that doesn't lock them into a particular cloud provider or particular software. What do you generally tell people to look at in that case?
It's a good question. The reason we've gone with GCP for the past project or two is because that's the ecosystem they were already in. So they weren't so much concerned with getting locked into that because they were almost alternative, willing to double down for some economies of scale.
It's not like you can go and migrate to another database easily.
Yeah, and that is it's a tough problem that is a little unavoidable to some extent, where if you want to go in the cloud, you kind of have to have it hosted somewhere. If you can do cross environments, though, as we talked about earlier, multi-cloud deployments. I'm pretty sure Snowflake you can deploy across multiple clouds. But then you're still locked into the Snowflake software. So depending on what tools you're using, there are open source tools out there. Apache has a lot of open source things that you can implement yourself, but you're going to have to kind of be using something, and whatever you end up using, even if you might not be paying for it necessarily, to then transfer to another software entirely is going to require some dev work to kind of convert that over. Was you going to comment on that, Ray?
Yeah.
Yeah.
I've heard good. I haven't set up data warehouse because I'm more a web developer, but I've heard good things about ClickHouse, which is an open source.
I haven't used it personally, no.
But heard good things about it.
Analytics database. Pretty popular.
So like that can be hosted in the cloud and then transfer to another cloud if needed.
You can also host your whatever you already use, SQL Server or Oracle. You can just host it in a cloud, right, without moving to BigQuery, like a cloud SQL instance.
You could also build it entirely in a VM and host the VM on the cloud, and then you can use whatever custom packages you want.
Oracle is not OLAP. It's very expensive very quickly. So this is something that I would probably be trying to avoid actually.
There are some open source OLAP databases out there. Yeah, okay, that would make sense then, yeah. ClickHouse it is.
Good plug.
Yeah. Cool, well that's everything I had. I appreciate you guys' time. Thank you.
All right, thanks so much, Scott, and big thanks to Jeff and Arlington Tech Exchange. Hopefully we have more events here. Thank you all for coming. There is still some pizza left over. Not a little bit cooler, but still there. If you want to help us finish that or hang out, 2 more minutes. Sounds good?
Yep.
All right,
Thank
you
you.
all.